Okay, a warm welcome to all of you to today's EUMETSAT user preparation webinar on EPS-SG multi-viewing, multi-channel, multi-polarization imaging mission, 3MI. EPS-SG is EUMETSAT's next generation polar orbiting satellite program, sorry. I am Shriyaka Thoniparambil. I am the EPS-SG user preparation manager, and we are at EUMETSAT, and we are organizing this next generation user preparation webinar series together with my colleague Stefan Bajinski. Stefan is the MTG, that's EUMETSAT's next generation geostationary satellite program. So Stefan is the user preparation manager of that. And together we organize this series in order to raise the awareness among our users on what is coming up in the next few years from our polar and geostationary programs. And we hope to stimulate some research and development in these areas, to use these products and data and products from these two missions. And today, 3MI, this is the fifth one in this series. So we had one in October 2020 on hyperspectral infrared sensors. We had one on lightning major in February 2021, scatterometer in May 2021, and just last week we had we had a 3-day session on FCI on board MTG and METIMAGE on board EPS-SG satellites. So in this way, we tried to combine those two because we thought that application areas are similar for these. And yes, today and tomorrow, we are going to hear from 3MI experts. You can see some of them in the videos, and there are a couple more joining maybe tomorrow. So this 3MI is primarily an aerosol mission, but it's also very important for cloud observation. So basically, clouds and aerosols, they are very important for climate monitoring, as you might know, but we also, 3MI is important for air quality as well. And as for EUMETSAT, our current polar system do not have a similar instrument. So this is very much a new kid now block, but those of you are familiar with polder parasol missions, you would know that this is not very new for you, but I think there is still a lot more potential for research in these areas. So with that, I just give a summary of what we are going to do today and tomorrow. So today, we will look more at Thierry Marbach. He will give a short introduction to 3MI instruments. So basically, what is meant by multi-viewing, multi-channel, multi-polarization, and how these level 1 products are generated from 3MI, and how what do the format looks like. So very practical information on how the level 1 data looks like. And tomorrow we will look more at the generation of cloud and aerosol. So there will be an overview talk on clouds and on the level 2 products. And there will be specific talks on on the generation of clouds and aerosol products, but we are also putting forward an outlook towards reprocessing of this data. So that's just an introduction from my side, but a few logistics during the event. We will use this tool called Slido to interact. So you can ask your questions via this tool. So just type slido.com on your web browser or on your phone, and then it will prompt for a code, put there 3MI, and you are in. Then you can ask your questions, you can upvote your questions, whatever you want. So you can also post your comments there. So not only questions, but your comments, etc. And use the Zoom chat only if you have any technical issues. We will try as best as we can to solve them. And one more thing, we will provide the presentations, the Q&A with the answers in them, and the recording of this whole session to you a couple of days after the event. With that, I think Thierry will show his video. I will switch off my video for bandwidth reasons, and I hand over to Thierry Marbach for his presentation.
Yes, good morning, good afternoon, good evening, everybody, because I saw in the list that we have participants from all over the world, which I really enjoy to see some colleagues joining and having the time for that. So yes, for those who don't know me, I'm Thierry Marbach. I'm remote sensing scientist at EUMETSAT, following the 3MI development since phase 0, so it's 10 years now. In my former life was more dedicated to trace gas retrieval, mostly formaldehyde, and where I wanted to avoid aerosol and cloud, and therefore it was very interesting for me to get into the world of polarimetry, but not only polarimetry, as you will see for 3MI, but also the synergy with the multi-view, which will be a very nice added value. And I hope that today and tomorrow, with the colleagues that we present on level 2 tomorrow, we will convince you about the utility of the 3MI. So today, as Erika said, it's mostly dedicated to level 1. I hope I can start my presentation. Yes. And I will start with a presentation on an overview of the 3MI mission, which will fly on the future EPS-SG platform, which will follow the actual EPS-SG. So as it will be a quite longer presentation, the first one, which approximately half an hour, I have made a short outline. I will present first a couple of slides about polarization for those of you that don't know what is the use of this capacity. The 3MI design, the 3MI level 1 product and generation, and the calibration also of the level 1 product. So first about polarization. So what is polarization? What we get on Earth, at least, is the unpolarized light from the sun that comes through the atmosphere, reflects on the surface, and then gets partially polarized. And this partial polarization light contains information about the medium has been crossed, and also the surface and so on. And with this information, it is possible to get information about this medium, and then we can get information on clouds, aerosol, vegetation, also surface product like sea and land surfaces. And this can be then, the polarized light or partially polarized light can be measured by the satellite. So now how we measure this polarization is basically using filters. On this example, you have vertical and horizontal filters, because the light that is coming to the satellite is partially polarized. So to get really to separate each component of the polarization is using filters. You can imagine to be like slits that filter the light. And to be more concrete, yes, I took this picture of my bike glasses in front of my screen. There are polarized glass that you can buy everywhere. And when you have the slits in open where the light can go through, because the screen, the LCD screen you have on your PC are emitting in polarized light. So here I get the full polarization light, so I can see the screen. If I tilt and I don't allow anymore the light to go through my glasses, I cannot see anymore the screen. So here I could say I have a vertical, or depending on how the slit on my glasses, horizontal polarization. In the everyday life, it's very useful to have this capacity, because then you can filter out, for example, here the reflection on the windows, you can see inside the house. Okay, not for any purpose. Also here you know that on the road, I was speaking about my biking glass, but I also use them for driving, so you can better see the road. It's very useful. There are more applications because you can better see. That's so interesting, some military application. One of my favorite book, which is very well written, to help me at the beginning, helped me a lot for the polarization. I'm still looking into it. You can see from the cover, it's quite clear for what can be the use. But on 3MI, we want, as I said, to gain information. So how we will do that? In a simplified way, we will have three polarized filter. It's 0, -60, +60. I will come that later on when I describe the design more in detail. we will have 9 polarized channels out of 12 spectral channels, and over 14 views. And combining spectral polarization and the geometry, the multi-view, will provide a lot of information content on the atmosphere, and then allow a very accurate retrieval of cloud and aerosol and surface product. So now about the design. As it was already mentioned by Serica, the 3MI mission is dedicated to aerosol characterization, mostly for climate monitoring, because we have the long-term data that will be, for example, for ICCP to allow to assess the impact of aerosol on climate, air quality monitoring and forecasting, numerical weather prediction. We also have the additional capabilities for the microphysics and also the surface BRDF and DVDF. And the 3MI will provide images of the Earth top of atmosphere outgoing radiance using the multi-view capability with the 14 view angular mean sampling of 9 degrees, multi-channel with 12 channels from 410 nanometers to 2.1 micron, and the polarization, -60, 0, +60 polarizer over the night spectral channel. The concept is a very simple one. It's a 2D push broom with 2,200 square kilometer swath and 4 kilometer pixel at nadir. We'll have acquisition every 20 seconds. That means approximately 92% overlap between two images. And a target will be seen up to 14 times with different angles. It's a strong, for those who know this instrument, a strong heritage from Polder mission with improved instrument capabilities, because we have the shortwave infrared channels and a larger swath and a higher spatial resolution. And it will be also an operational mission. 3MI will be operation. This means long-term acquisition of near real-time data dissemination over 3 consecutive instruments. So that means 20 to 25 years at least of data. To show you how 3MI is on the platform, so we will have on EPS-SG, we will have 2 platforms separated by a 90 degree on the same orbit, separated by 90 degrees. 3MI will be on the first platform, which called EPS-SG. It will be beside the microwave sonder and also the Copernicus Sentinel-5 mission, which will be a UV, an infrared, shortwave infrared sounder, the METIMAGE, which will be the visible infrared imager, and the YASI-NG following YASI instrument on METOP, which will be the Fourier transform imager. Also, radio occultation will be on board. The second platform, I put it smaller, but it's the same size. I wanted to put the focus on the first platform. The second platform, METOP-SGB, will be more dedicated to microwave instrument with the microwave imager, the ice cloud imager, and the scatterometer. Also, radio occultation will be redundant on the METOP-SGB. The first launch of METOP-SGA is planned to be 2024, and after that, every 7 years, so up to 2038. More in detail about the design. Easy design is 2 optical heads with dedicated detectors and a filter wheel also associated to each optical head. The first optical head will be the linear optical head, visible in infrared, with a CCD detector of 509 by 509 pixel, and has a dedicated row of filter on the filter wheel. And the second one will be a CMOS detector with a 255 499 pixels size, for the shortwave infrared optical head, also with dedicated filters. You notice that the detector, the sphere detector, is half size of the linear one, And this has been partly compensated, is actually a nice mitigation, by doing 2 acquisition of the sphere channel when you do only 1 acquisition of the vignette. This is possible because for one view, the filter wheel will rotate 4 times. And so the first rotation will have the full acquisition, and the third one, it will only be the sphere. So it's, as I said, a nice mitigation. Here you can see on the top the picture of the instrument provided by Leonardo, who is in charge of assembling the instrument. So you can see here nicely the 2 optical heads with telecentric optics, so very wide field of view, and then the filter on the filter wheel. Yes, very important as well. The 2, the shortwave infrared and the linear filter have been synchronized, putting same acquisition time, very important, I mean, very important pair of filters that will be mostly detailed tomorrow in the level 2 presentation. Very important for better accuracy of cloud and aerosol retrieval. And here the simulated radiances that has been done by University of Lille. On the left side, you can see an RGB composite with 3 channel, and you nicely then with a very wide field of view flying over the Earth. And on the right side, this powerful of polarimeter, which is the polarized light, and especially also that will be shown tomorrow, this cloud bow, where you can do the difference between liquid and ice cloud. This, I think, remember, Jerome will show that tomorrow in the level 2 presentation. Now I will present you the generation of the level 1 product and what we have at level 1 product. We will have 2 kinds of level 1 products. We will have the level 1B and level 1C, both in NetCDF format. I will start actually with the level 1C because it's the most known for maybe the most of you, because it's very similar to the polder and parasol one. So it's the geoprojected stock vector. And on 3MI, we include additional information from EPS-SG, which is on the same platform as you saw before. So cloud information and inhomogeneity information. I will detail that in the coming slide. And in addition to that, we will have the level 1B, which is the stock vector in the acquisition geometry. And we'll give that for the second, the geometry of the second polarizer. Why? This was a request also from some user to have the images without any bias due to the projection on an equidistance grid. So can be, for example, useful for tracking clouds and so on. Here again, what is the level 1B? So each acquisition for the satellite motion over a target, this is then even each single image is the level 1B. And the level 1C is everything reprojected on the Earth surface on a reference grid for one target. So you will have all the information for one target as it was for polder, but with the additional meta-image information, with the subpixels information, and also some cloud information for parallax correction. Very useful. Now about the generation of the level 1B, coming one step back. We have, of course, inputs, which are the level 0 product, and some auxiliary data, like, for example, the calibration coefficients, and the output, level 1B, and update of auxiliary data, like the calibration. In between, the level 1B product generation function, which can be shown as that. We are using an IDEF0 scheme. So we are first ingesting the data, then the important block is the processing algorithm. I will detail that a bit more. And online quality control, and then formatting to the level 1B and exit to the output. So I will detail a bit more the processing. We will have two parts, the radiometric correction and the radiometric inversion. The correction is also known steps for optical instrument. We have the non-linearity correction, the background signal correction, smearing, only for the CCD, so only for the veneer, stray light correction, and equalization. And radiometric inversion will have a pre-processing and a post-processing, mostly placeholder to do some filtering if needed, and also the geometrical registration. And then the bigger part is the polarized channel retrieval and the non-polarized channel retrieval. I give you an example here for the, not starlight, but stray light. It was a wrong correction from my PowerPoint. The stray light correction, and especially the outer field, because as we have a telecentric objective or optic, the contribution of the outer field is not to be neglected. So we have developed an algorithm that takes into account the previous image and the next image, and possibly also to mirror on the side to extend, to simulate the outer field for the stray light correction. This looks then like that. So you can see here the added part from the previous view, the next view, and then the mirroring here on the side. This to allow to have a better correction. The most we can get out to correct the stray light and to have a nice image. Now to the level 1C. Generation is basically, if I would simplify, projecting the level 1B on one equidistance grid. We have some additional information to that. I will come to that. So we take all the level 1B view and we look the overlap of all the views, which also is to have to be to overlap the across scan of MET image, which is approximately that size, a bit larger, but in the along track is approximately that. So we can add the MET image information also to the level 1C, and then project it to a equidistance grid, like for example, this sinusoidal reference grid. Then it looks like that. You have all the crop area are put after each other for veneer and sphere. And yeah, the additional VII parameter, I also wanted to highlight that. So don't get confused. VII and MET image are the same name. It's just about specs. You can see here the same name. So it's exactly the same instrument. So when I speak of sometime about VII or MET image, it's the same instrument. So we are adding, as I said, cloud information, so the cloud fraction, cloud top height for parallax correction, for example. And one I want to go a bit more in detail because it's maybe less known, is the scene inhomogeneity. So what is that? This will allow you as the user to know which level of homogeneity each 3MI pixel has. And this is very important because most of the error, I can zoom on that, because MET image will give you has a resolution of 500 meters, and average on the 3MI pixel, we can give like a flag on each 3MI pixel, which inhomogeneity is in that pixel, because many errors are correlated to that inhomogeneity. So important for cloud retrieval. But also, for example, later when we will do some surface product like VRDF. So very useful and information added to that, to level 1C. And here then what the level 1C looks like. So on the left side, you have the total radiance for each spectral channel and each view. So it's gaining each one after the others. And on the right side, you have the associated scattering angle, which is the third part that of the 3MI. So you have the multi-spectral, the multipolarization, and the multi-angle. And that means also the multi-angle is that you have this powerful of the geometry that can will allow to get very accurate retrieval, especially when you have wide scattering angle differences. And yeah, as I said, not only total radiance, but also the polarized radiance with the same scattering angle associated to that. So very, very curious to look forward to use the real 3MI data for that. Now for the calibration, which is for an operational instrument very important. It will be based on what we call the in-flight vicarious calibration, which means calibration using natural target. So it's developed in close cooperation with CNES because of the great and powerful heritage they have on polder parasol instrument. So as I said, it will be based on using vicarious calibration method because the 3MI doesn't have onboard calibration device. It would, for the telecentric optic, it would have been a huge onboard calibration device. But it was demonstrated already for parasol polder that this natural target technique is very powerful to assess the absolute calibration and other degradation during lifetime. So with like a toolbox using the oceanic target with Rayleigh scattering, sangline. So the variant calibration site like desert sites, Antarctica, which is also a cold desert, cloud target, like the deep convecting clouds, and the moon acquisition, which has been granted for 3MI for the commissioning. And as I said, it's a toolbox, and the combination of the method is the powerful of this, and will allow to cover all the spectral range and all the coefficient that has been to be assessed, including the polarization sensitivity. And the goal is to develop a standalone calibration tool for 3MI. But as I showed you on 3MI is not flying alone, it's flying on over a platform with other instruments, which will allow simultaneous observation with METIMAGE and Sentinel-5, which have onboard device. And then we can have further calibration and synergy, also for product, by the way. Listen tomorrow, where will be very interesting on aerosol synergy. And also 3MI will allow to correct for anisotropy those instruments and also help them to monitor the degradation, for example, of the solar diffuser. It's a given and taken. So it's here you can see simplified the synergy we have on EPS-SG on the first platform. So we have the 3MI that will benefit from METIMAGE for radiometric calibration and complementary channel, for example, the thermal one. And Sentinel-5 will also allow spectral calibration and complementary channel. I'm thinking about the UV. And 3MI will allow through this product to assess and help also correct anisotropy and especially through the microphysics to improve the product of METIMAGE and Sentinel-5 and ESG, and also the synergy product that will be developed tomorrow. So here again on the table, the very good overlap between 3MI and METIMAGE for the radiometric calibration, and also Sentinel-5 for the spectral calibrations. As I said, great number of opportunity. Of course, it's assumed a well-calibrated METIMAGE and Sentinel-5, and with that we have a huge potential of calibrating for radiometry, spectral, and geometry. So now coming to a summary, I think the half an hour is already almost over. 3MI will provide a unique long-term and operational time series for atmospheric characterization, aerosol and cloud, and surface product will come later. It's a high maturity level thanks to the strong polder and parasol heritage. It's scientific and also an instrument. The multi-view, the multipolarization, and multispectral concept is very simple. It is a two-wide field of view optics combined with a two-stage filter wheel and a 2D detectors. The spectral extension to shortwave infrared and a 2,200 square kilometer field of view and an ideal resolution of 4 kilometers is the main improvement towards parasol. And we will have the level 1B, which are the geolocated in acquisition geometry, and the level 1C, the geoprojected and register acquisition as for polder parasol. Both products will be available in NetCDF. And the in-flight performance will be monitored and maintained through VCAR's calibration techniques using natural target, as already done for other sensors, and as well with cross-calibration with MET-IMAGE and Sentinel-5. And I think this was my last comment. Thank you for your attention. And of course, open for the question. I hope Sirika has already a couple of them.
Yep. Hey, thanks, Thierry. I think somebody's not muted. Okay, please, yeah, put forth your questions to Thierry on 3MI on the Slido tool. I hope everyone has got access to this tool now. If there's any problem, let's know. And it's quite exciting. There are about 120 participants in this webinar now, so quite important. Yeah. Thank you, Thierry. And also thank Thierry, you did a lot of advertisement for tomorrow's talks as well. So I hope it works, you know. And also thanks for mentioning the surface. I mean, in my introduction, I forgot to mention the surface, of course. The surface is quite important too. So with that, I just bring up my screen on the questions. Yeah. I'm getting used to it, yeah. Comes now. I think I just, this meeting controls, yeah. So Thierry, there you go. What's the spatial resolution of 3MI data?
Yeah, it's 4 kilometers at nadir. That means at the edge of the field of view, it can be double size. The pixel will get wider. But when we will do, this is for 1B. For the 1C, they will be all projected on an equidistance grid with 4 kilometer resolution, about 4 kilometer resolution, is a bit less.
Mm-hmm. I think there's another question. Are the simulated data available for public use?
Yes, it's in the coming presentation, Kirk.
Yeah, the links will be provided, yeah. And then are there RTMs that support the stimulation, thus assimilation of 3MI radiance? Something that I wanted to ask also. So
are the RTMs that support the stimulation and thus assimilation of 3MI radiance? I didn't get the question really.
About the I think it's mostly about, I mean, I would say that it's RTMs is radiative transfer models that support the simulation. So something like RT-TOF that can. Ah,
okay. No, I got it.
Yeah. Mm-hmm.
I would say in principle, yes.
Yes.
I will just take the sentence from Oleg. There are RT-TOF that will be soon ready to support polarization. I hope when 3MI will fly, but we also look to other RTMs. I mean, also on the side of University of Lille with Art Deco and so on, that can support this, and also with the KNES development, because for the calibration also we need RTM that support this, and then is all the 6S based RTM, and yes, we have already this available.
Mm-hmm. I think, yeah, quite computationally expensive, I would say, yeah.
Yep.
And Thierry, if you allow me, I think the question is, yeah,
please, Jerome, yeah.
The simulated test data have been indeed simulated with RTMs, and specifically it was done using Art Deco and adding doubling code and so.
Exactly.
Thank you, Jerome. And the assimilation of 3MI radiances, Thierry, do you?
Could you briefly mention some speaker?
And no,
okay, for MET-IMAGE and UVNS. Okay, the spectral characteristics. Okay, MET-IMAGE spectral. What do you need? The spectral resolution, because I don't have it on the top of my head for MET-IMAGE and UVNS. I can provide the website of EUMETSAT. Everything is described there. it could be useful for anything. I mean, the spectral resolution of UVNS is, I know already, is higher than, of course, for the 3MI one. That's the reason we will use it to calibrate spectrally the 3MI.
Mm.
Yeah, it will
we
be
can
similar to
provide
what
this
another space
information.
mission will have, exactly. Yeah.
Sorry, Thierry, maybe I interrupted you, but I
Yep.
think we can provide this information offline as well, right? If there's
Yes.
available. Yeah.
Yes.
I think in that question that we took earlier, there was a question on that and the end about the assimilation of 3MI radiances, but I think this is maybe something that is not yet there, but might happen in the future, right?
No, I think we already answered that one. The assimilation is no. They are already achievements that supports the assimilation of 3MI radiances. Yeah. It's done.
With that, yeah. Why do we need BPDF?
It's not me, it's the user that wants them. So for what we need them, I think for our main user are the weather and climate agency. I mean, it's to increase the retrieval over surface. You need to better, at the moment, many proxy are put as a surface a priori, and when we have better BRDF and BPDF, it can maybe improve those products. For the BRDF, I know, but the BBTF, yeah, we have to see. It's mostly a level 3 product. It's not the biggest focus for 3MI.
Theory, BPDF is bidirect
Polarized difference, function.
Yeah. Okay. The other one is the RDF, right? Yeah. BRDF and BPDF.
BRDF is bireflectance.
Right there.
Function.
Okay.
Sarika, could you come back to the question about the MET-image and UVNS? Just 1 second.
I don't know how to bring the question back, to be honest. But
okay.
Okay.
Don't worry.
About the characteristics of MET. Yeah, it has come up. Stefan, thank you very much. Could you briefly mention some spectral spatial characteristics of the MET image and UV?
Yes, because the second part of the question was related to the synergy between the sensors that is possible and the fact that it is something foreseen for the NASA space mission. So the answer is yes, absolutely. This is something we have on the pipe for the development to support at least cloud and aerosol retrieval, combining MET-image and 3MI for sure, but also the other sensors from the platform, especially for we have clearly in the plan to develop an aerosol product combining UVNS and also ESG on the platform. So yes, the answer is yes.
Thanks, Bertrand. Everyone, that's Bertrand Funi. He's also another 3MI expert, not just 3MI, but expert.
Exactly.
Yeah. Okay, so I just clicked that out. Does VII stand for Visible Infrared
Instrument? Exactly. Yeah.
How is the BRDF characterization done for partly cloudy pixels? Can the cloud and surface BRDF be distinguished then?
I don't have the answer for this one on the top of my head. Maybe we can give it tomorrow while we are answering or presenting the level 2.
I don't know if Isabel is in the, I think I saw Isabel in the audience. I don't know if she's the right person. If she wants to talk, she can raise, I think she can type and maybe give, I don't know. Okay, it's possible, yeah, that the audience, just in case you want to.
I see a lot of questions about surface product. Okay.
Yeah, I actually, yes.
It was worth it, you see, it was worth to mention it.
Yeah, true. I think, do you want to take then the BRDF?
As well for tomorrow, yes.
Tomorrow, yeah. So we take the BRDF question tomorrow, yeah? Then I bring up another one. Thank you for your introduction. I wonder when can the level 1 products be available for public?
They are public, and I will give you the link in the following presentation.
Yeah, that's a test data, yeah?
Yeah, exactly.
But the real data comes after the launch, 6 months after.
Yes, we usually follow that order.
Yes. Okay, this is the one that we want to take up for tomorrow. I just bring them up, okay? Are ground-based data such as Aeronet used in the CalVal campaign?
Yes. Yes, it's foreseen, yes.
Okay. Could you, I just bring that to the top. Could you please confirm that 3MI uses the telecentric lens like folder for the L1B data? Would a user be able to obtain the technical camera parameters, which would be necessary for the application of image processing techniques?
Okay, I confirm use telecentric lens like as polder. It's even a wider field of view as for polder. And for the distortion law, I think it's something we can even provide on the EUMETSAT webpage. So if a user wants the distortion law of the optics, it's something we can provide. There's no problem about that.
Mm-hmm. I think that finishes all the questions, Thierry. Thank you very much. But before we go to the next question, I don't know. There's one more question if you want to answer it. How is EUMETSAT planning to involve the scientific community in the preparation of algorithms for 3MI tenders?
Okay, for level 1, it's not tenders. It's done in cooperation with industry and also CNES, which is helping to develop the level 1. For the level 2, is also no tenders foreseen, because it's what we call, everything is done with, I will show in the following presentation with the payload data acquisition plan. So we have this development already ongoing with Thales, who is in charge with the prime for the processing, and but what we foresee is to have some tenders. This is for sure. Because a good algorithm is a algorithm that is validated by another one. So we might kick off studies or tenders to have some validation algorithm of our product. This is always good. Like I think PACE mission is doing something similar with GRASP and the algorithm. I forgot. Sorry, Otto, if you're offline online, I forgot the name of your algorithm. So the SRAM algorithm, basically.
Mm-hmm. Okay. So just don't know if there's another one. So
I could propose to readdress this question tomorrow after the level 2 discussion. Could be useful.
Mm-hmm. Okay, Bertrand. There's one more question. The three 3MI instruments, I think it means the one on the subsequent satellites as well, will be identical or improved from a generation to the next one?
Identical. This is also to follow the operational needs of EUMETSAT. We cannot change too much between instruments.
The processing can be updated.
The processing will be updated, as well as the calibration. I mean, of course, for this, we will take into account the improvement, but from the hardware will not be changed.
Mm-hmm.
We have to keep in mind that what EUMETSAT is committed for is the production of operational products, so aerosol and cloud product at the end, level 1 also. And the rest is something internal. The way we have to, because we want to provide this data for the next 25 years, the rest is a system that we have to put in place to guarantee this delivery for the 25 years. So the fact that we need 3 instruments is the way to cover this time series. And of course, if we want to provide a consistent time series for this data, we need as much as possible to have 3 similar instruments and processing and everything.
Yeah, thanks, Bertrand. Take off that as well, I think.
Mm-hmm.
Distortion low.
Yeah. There's this yeah, it's not the name we will use. I think it's someone from ESA writing here because it's the wording from ESA. We will have in our auxiliary data, and maybe we will not put in our auxiliary data, but on our webpage, the distortion law.
I see.
This I was sure that we have it, but how we provide it to the user is another thing. We will put it on the website somehow.
And by ICDB, it's some calibration database.
Yes.
Mm-hmm. Just for those who are not familiar with that. I think there's one more.
The PM 2.1. I was waiting when the PM 2.1.
Is there a plan to develop this product air quality monitoring using 3MI? If not, why not?
No. Okay, it's not. We are thinking about the PM 2.5. It's not at the moment because for the start we need some, I would say, robust product to test the 3MI in the first month. So commissioning which is over 6 months. But after, as we said before, the algorithm will evolve. And we might also, of course, provide the PM 2.5. It's one of the suggestions, of course.
Mm-hmm. Looks like now we can go for a break, but you can still type the questions because I think we are a bit, we do have enough time to take the questions after Thierry's second talk. But before that, I would also like to tell you that there's a small survey on this session, today's session, that you can try to answer. This will help us. This is like a feedback for us. So this will help us to improve, when we do this another time, or we have some more user preparation webinars that are coming up in autumn. So I would encourage you to put in your comments and feedback. Stefan will now type in some of the ways how you can go and express your opinions. There will be a link appearing in the chat. So that's one thing. So please do that. And also please, I think we will take this last question after the next session, and then we go for a break now. So we will be back at 14:55 CEST or 12:55 UTC. Okay, see you.
See you. That's the reason, indeed, we would like to propose you to download and to look by yourself the test data. But anyway, first, in a high level, this presentation is there to present you what you will get as a test data. So you will get test data for the level 1B. Here you will see how the product is named. So you will get of course, EUMETSAT. The satellite will be SGA. Of course, for the first one will be only one, but at the end it's one from 1 to 3. 3MI 1B radians. So you can see this will be the 3MI 1B, and then the acquisition time. And the description will be top of atmosphere spectral radiance and reflectance factor. So it's not radiances; they are already been normalized. So reflectance factor units. As it was for polder. So it was very similar to polder. It's just a different name, but actually the unit or the non-unit is the same. For the polarized channel, we have the stock parameters on the native grid of the second polarizer. It will be NetCDF format, and for the level 1B for one orbit, we estimate at 6.5 gigabytes. So it's a quite it's a nice data size. Then on the top, you will have also the level 1C that will be distributed and to which you will get test data. The naming is similar. You just replace the B with a C. And it's the stock vector on equidistance of reference grid. and also netcdf format, and the estimated size is also about 6 gigabytes. So how it looks like. So this is the netcdf structure, the XML structure for netcdf. So you will have the root with global dimension and global attribute. You will have the status with satellite, instrument, and processing status information. Quality group for different quality information. But the most important, I think, what you would like to look at is to the data. And for this, I just put you the structure for the view. So the data will be distributed in view, and then you get the spectral information with all the IQU information for each view. So the highest levels of view, then comes the spectral channel. The 1C is quite similar, so I will not come back to all the detail. The only difference is here. The data will be structured with what we call overlap, which then have all, overlap will have all the geometrical and spectral information for one overlap, so for one target on the Earth. This is the main difference between the handling of the level 1B and the level 1C. But the best thing is to download this test data. You can do it on the website I put in yellow. So it's public domain. You can download the information, and also we have put some test data on the FTP server. If you have any issue, contact me or whoever from this panelists of today. We will come back to you and give you the information you need to get access to this data. It should work. Colleagues have already tried, so enjoy. And provide us the feedback if any. The level 1C have just been produced as well, and will be available on the same page soon. Meanwhile, if you want to have more information about the level 1C, we have also algorithms that are publicly available, so or at least studies. And if you want to know more about the level 1C core registration algorithm for 3MI, go to this website. And again, if you have no time, the slide will be distributed. Sirika said the slide will be distributed, so you can then go to this website or just contact me if you missed the information. The dissemination, as said in the previous talk, it will be an operational long-term framework. So again, 3 consecutive identical, I will add that in later slide, 3MI instrument. This is important for to have the gapless and also consistency of the data. We cannot change easily the hardware, but the software, the data production will evolve with the latest finding, and the data will then be reprocessed. This will be the talk you will see tomorrow, also for climate application, but not only. This is done for many instruments at EUMETSAT, that every time the software is changed, we reprocess the previous data to have consistent data set. And it will be near real-time dissemination. That means for the level 1B product, it's about 105 minutes for the 50% of the data, but we have the requirement for 150 minutes for 100% of the data. Level 1C is still under confirmation, but it's 5 minutes after the level 1B. And we have also regional product. I will show that difference on the latest, on the next slide, but with quite similar, at least for the 100% data is quite similar to the global product. So here you have the description, what we call the payload data acquisition and processing, which are, it was the question I had from the previous presentation, which are developing the algorithm for the level 1 and the level 2 product, not only for 3MI, for all the instruments. The satellite is sending down the data to regional station, and then we get regional data fed in this processing. I will come back later to this processing facility. And we have also the global data that I download on the Polar station, which then offer the global data. Then inside the PDAP, the payload data acquisition and processing, what I showed, this is a general view, but I showed you in the previous presentation what is done in terms of processing for 3MI. So you get basically this is the level 0 product, and then you get global level 1, level 2 product, global regional level 1 and level 2 product, and also the accelerate data update for local user. The EUMETSAT, for those who are already know the data management, we have it will be a follow-on for the EUMETCAST for satellite. It will be maintained. We will have with near real-time push. We have the long-term archive with data preservation and offline media request. We will have a download service with centralized data and download and tailoring, and a view service with enhanced web map and coverage and feature. And this will be done in for the user will be able to have a customization of a toolbox, which basically will allow to do some aggregation and then projection and resampling, layer filtering, reformatting over region of interest, and quick looks also. So it's this will be available also with this data. And I think it's already a version that can be tested. I'm not sure, I have to check. In summary, the presentation is shorter than the previous one because you can test by yourself the product and the format. The level 1B and the level 1C product has been defined, and the implementation is progressing. The product format have been defined using NetCDF4 as a native format, and are described in what we call a product format specification that are also distributed with the test data. And the global and regional product follow the same processing, and the format for global and regional product are identical. And the test data are prepared for 3MI and other instruments. On the website I gave to you, if you click around, you will find test data for other EPS-SG instruments. It's based on the simulated top of air atmosphere radiances done by University of Lille, what I showed in the previous presentation. And the data are already publicly available, and I'm happy to get your feedback on that. And that finish the product and format presentation, Zirika.
Thanks, Thierry. Just want to mention you that the level 1C test data is also released recently.
Okay.
In April, we released the level 1C data. I can also put that in the chat, you know, the link to level 1C test.
Or give me the link and I put in the slides, and then everybody has it.
Yes, that's another way of doing it. Yeah, I think just to mention that all the EPS-SG test data as well as MTG test data are available in our web pages. So if anyone feels keen to look at them, just have a look at our external web pages. Go for test data for each mission, and you will find them. Okay, so with that, I think I go to the question and answer sessions. Okay, Q&A. Full screen. Share screen. Okay, theory that comes up. I think this is what. This was the question that came back from the last talk, actually, the plans to, let me just remove my meeting controls. Yeah. What are the plans to continue the ice liquid cloud climatology provided by Polder?
I think this one is for Jérôme.
Yeah, and that's a good question. I will address that tomorrow during the level 2 product, but the short answer is yes.
Okay. Okay, we give it, maybe
Start with the short answer.
Sorry?
No, you should have given the short answer first.
Yeah. I think maybe the presentation also will cover some aspects, and if not, we take up this as a question. So I leave it there anyway. There's a question, considering the potential of 3MI together with MetImage for nowcasting example fog, will local processing, its local mission support considered in the near future?
3MI at the moment is not one of the instruments that is foreseen in the local processing. METIMAGE is, but not 3MI. When everything is in place, when we see, it's about downstreaming, and the 3MI was not foreseen to be a forecasting support instrument, more climate-oriented instrument. But when the data rate allows it, I think 3MI can also become local processing. Yes.
Mm-hmm. It's not near future. Yeah.
Not sure. No.
I think this one comes up. As you mentioned, the 3MI pixel will change across the satellite path. Will there be enough information in the data fields to calculate pixel shape, size for accurate assessment at different viewing geometries?
Yes, because if you can deal with the first, you will get the lat long, so you will be able to calculate your own pixel. By the way, the lat long, latitude and longitude, you will get in two kind of information with on the geoid and with DM, digital elevation model correction. And this is given you with a delta you can add to your geoid latitude and longitude. So with that, you can calculate your pixel shape. If you want to do kind of, this allows each user to apply his own DEM, for example, its own digital elevation model if he wants to use a different one we are using. No to the size, so this gives you an approximate size. If you want a more precise size, as we said, we will also deliver the distortion law, probably in the through a website and or maybe in the calibration group of the test data.
This for the test data, the level 1C or level 1B, which of them is? I think it's a level 1B is
level 1B has a distortion because it's a native grid, and when you project the square on a sphere, you have it looks like a butterfly, if you want. The 1C will be geo-projected, but you also lose kind of information on the pixel at the edge because they are merged in equidistance pixel on a reference grid.
Okay, and the data are provided on type points, or is that for both of them?
Yes. The lat long you will get in type points. With also in the test data you will get the formula to reconstruct your type points. It's a quite simple reconstruction. It's not something difficult.
The product format specifications has.
Yes, we'll have the type point formula inside. Yes.
Okay, that's some information. So I click that answer. I think, yeah, I bring that up. I'm not sure that latitude, longitude alone are sufficient to calculate true pixel shape because the distortion means there will be overlap between off-neighbor pixels, or will you provide pixel corners and or ellipse parameters per pixel?
I don't think there will be overlap between off-nadir pixel. I cannot say there will be distortion, but there will not be overlap of pixel nadir. No, this is not possible because it's not a scanning instrument. It's you take the picture in one shot. Is a push broom instrument. So with the distortion alone, distortion law, you can recalculate the distortion or with the latitude and longitude.
Mm-hmm. I think I saw. You can bring this from Bastian. Will the level 1C be projected to the surface only, or can it also be projected to cloud top?
Yes, it's an ongoing discussion that maybe, I don't know, Jérôme, if you will present that tomorrow, but we also think the correction is done with the parallax correction is done assuming the cloud top height. So it was with that actually you can change your 1C product if you wanted to see the surface or the cloud top. Now is that Jérôme, if I remember well?
Yeah, there is a mechanism in the new level 1C code to actually do the registration at the scene altitude. So I think on the baseline, like right after the launch, the baseline product will be reprojected to the ground, but there is also a mechanism to use ancillary data. So it could be the MET-image oxygen A-band or the 3MI oxygen A-band laptop, and that can be used to derive the scene altitude, and from which the level 1C software can reproject at altitude level. And I want to mention also to users that as opposed to polder, both the level 1B and the level 1C will be available.
Yep.
That's a big change as well. So for those users who are interested in the full resolution, non-reprojected data, that will be available as well.
So that's a change from the polder.
Yeah,
where only the level 1C was available.
Maybe that's the reason I got this question 2 times. You don't need on 3MI to calculate your own distortion. You will get it from the level 1B. You will get. You don't have to do your breakdown yourself.
Mm-hmm. Yeah, so that's a change from the.
Yeah, from the.
Maybe that.
It was a need, and we reflected the need. So
mm-hmm. Is there a higher level of product than level 1C?
For the level 1, no. The level 1C is the last product. After that, we go to level 2. Level 1C is the input to the level 2 retrieval.
Okay, just do that. Let me bring that up. Thank you for the presentation. Currently, test level 1C data covers a part of the orbit. Will there be more test data available? A full orbit, several days of data. Yeah, please.
We will get 3 orbits.
I think next year, sometime next year, if I remember.
Mm-hmm. No, I think if you told me the 1B are already the 3 orbit. Ah, no, wait.
No.
It's already a quarter of orbit at the moment. Yes. I think by mid of the year, we should get the 1B for sure, and the 1C will follow by end of the year, yes. For 3 orbits, yes. They are currently under processing.
Okay.
On the same web page, just...
Yes, there will be an announcement through our usual channels when the test data is released, and then you will find them. I mean, they will be available as separate pages as per the release, but we also append all the releases in one page for the users. This is where I mentioned this one test data page for each mission. Okay, so the next one, what will be the time lag, maybe, time lag for near real-time data?
It's 115 minutes for the level 1B in global dissemination, which will be the most used data, I think, for every people, which is very close to the regional dissemination, so it doesn't make so much difference.
Mm-hmm. I think there's a similar question. The test data files seems to cover less than 1 minute of observations. Should we expect this to be the distribution rate for 3MI operations?
It is 1 minute. It's quarter of orbit, and 1 orbit is 9. How much? No, it's less than 90 minutes. It should be more than 1 minute of data. It's strange. The person who can contact me directly if has difficulty, I think it's more than 1 minute of data, because only to tell you, only to have the full coverage over one target, I mean, the instrument fly over itself is already 5 minutes needed. So it's certainly more than 1 minute of data.
Mm-hmm. I think we get back to this question when
or the person contact me, maybe it's not the right link or something like that.
We will provide a Q&A with answers,
Okay.
And squeeze this in there so you don't get contacted directly, but that's also possible. But I'm just telling, we have to provide answers anyway, so we put that in there. So there's a comment from Stefan that says 1/3 of an orbit is about 34 minutes.
Yeah.
What did I do? I did something. think these are the questions we wanted to take tomorrow. Yeah. 3 questions.
There's one more. That
There are some more.
Yeah.
Sorry, if I understood correctly, the number of view angles can be increased from 15 angles. Is this true? If
Yes.
so, will this be implemented? It's from Basti.
Okay, there's difference on what is possible and what is, I mean, it was in the spec. Again, as an operational agency, we have specs. That mean at level 1C, each pixel should at least see 14 views. Some pixel might see more than 14 views, but we cannot guarantee that for all the pixels. So at least we need the 14. Maybe some will have 15 or maybe 16 for some extreme cases. It's maybe also possible. But this is not something we need to guarantee to the user. You will get 14 angles, which is actually not bad.
Thierry,
Yep.
maybe this is a very educated user that asked the question, I don't know, but it could be also the question is, technically speaking, 3MI could actually get double sampling.
Yes.
It's mostly a data rate issue that we will not meet all,
yes.
all observation. But in principle, there is a mechanism to oversample and have double the angular sampling.
As a,
if
yes,
the data rate allows.
It's true, and we have this possibility because we have the, as I said, for one view we are using 1.5 wheel turn on the 4 wheel turn we have, so we could do a more than double oversampling. The only restriction is the data rate and the data storage. It's a huge, it's just doubling everything. And at the moment, if this user wants to buy us additional reception and data storage, there's no problem.
Yeah, I guess the options we have is that we could decide to lower the sampling from one band to get more sampling from another channel. So as a user, as a scientist for the
I know we had that discussion already.
If there are users in the room who would like to have this capability, I strongly encourage them to provide this feedback to EUMETSAT.
For commissioning, we will test that, and we will see how this can be maybe implement at low cost of data downstream and data storage. But we cannot, at the moment, the spec 14 angles, and we will follow first those of them, which is a, as you have to understand, is a threshold. We have also objective specs and breakthrough specs, and what we have to guarantee is the 14 angles. Then after, what's come on the top is a nice to have for our side.
Mm-hmm. Shall I move on? I think there's one question on 3MI on the MET image test data, and I can answer that also. Yes, we will have MET image test data with 3 orbits, same like 3MI. We will have
all instruments follow the same procedure.
Yes, EPS-SG, all instrument follow the same procedure. Now I don't see any more. Other than the ones that we kept for tomorrow. Yes.
Okay.
Yeah. So just to note that these questions we will take tomorrow. Either, some of them could be answered directly by the presenters, or we can also take them up. For example, the BRDF, we do not have a talk dedicated for that. So I think we need to, let me just bring back my controls. I think we need to take that up separately. I think Bertrand would like to discuss that a bit, and a bit of other stuff too. So I'm hoping that we can do that tomorrow in the time. It's a bit more packed than today, tomorrow, because there are more talks tomorrow. Today was just an introduction to the instrument and the level 1B, but there's more meat tomorrow regarding level 2, which are directly linked for the application scenario. So I think, but still we would like to get a complete picture. Yeah. So we will take these questions and also some additional points that Bertrand want to raise tomorrow. So that's it for today. Yeah. Thanks, Thierry.
Welcome.
Well done.
It was my pleasure. It's a nice thing. I like to do that.
That's really good to hear. We will do more then. So thanks everyone for listening as well. I still see many participants remaining, and I would like to encourage you to also participate in the polls. We would like to do better every time. So we still have 2 more webinars in this series coming up, at least for the observation missions. There will be one on the microwave, or the microwave images, sorry, microwave sounders and images as part of EPS-SG, and also on the radio occultation. They will be in autumn sometime. But together with the Q&A, like I said before, we will send the Q&A, the presentations, the recording, everything after the event. But we will also put in all the links to the slide, to the test data and everything there. We just need to keep that in mind. Okay, with that, I end today's session and wait for tomorrow. Thank you.
Thank you.
Bye, everyone.
Bye-bye. Thank you for attending.
Bye, everyone.